So here we're looking at the Poisson distribution. Now, Poisson distribution is a discrete event at a continuous but finite interval or time or space. So it's measured per unit of time or per square metre or something like that. The events can be counted but can occur at any time or at any place. This will come clearer with a little bit of an example with it. There are no fixed number of trials, unlike the binomial distribution, and there's no upper limit on how many times the event can occur, so you can keep counting them. The Poisson distribution is often known as the distribution of rare events. Example, volcanic eruptions, breaks in a fibre optic cable, that sort of thing. So here's some examples. So, number of oil tanker accidents per year, the number of emergency calls per hour, and you notice there's a bit of a common theme coming out here. Number of wekas per hectare of bush, number of eels per 100 metres of stream. So that per is really common there. So it's a counting thing per either a time or a unit of area or a length or whatever. Features of Poisson is that it's a discrete distribution, so we can only have whole numbers of x because we're doing a counting thing, so you can't have 1.5. There's only one parameter involved, and we use lambda, which is the mean. Lambda is proportional to the interval, so if you have 24 storms per year, for example, lambda is 24 for the year, but if you divide that by 12, it'll be 2 for each month. Lambda can change. So you need to remember to read the question carefully. If we're looking on the graphics calculator, we go to menu first, go to 2 for the stats, F5 for the distribution. We need to go on to the next screen, so you need F6 for that arrow, and then for F1 for the Poisson distribution. And then from there, you either choose the PPD for the precise distribution for a particular distribution, a particular value, or you can use PCD, which is cumulative distribution, so it's up to a certain point. Mu on the graphic calculator represents lambda, so our mu is just our lambda. So let's have a look at an example. So on an average, a household receives one wrong number per day. So we're going to calculate the probability that it receives, firstly, 2 wrong numbers on a day, and then no wrong numbers in a full week. So let's look at A first. So we want probability x equals 2. Now our lambda equals 1 because it's one wrong number per day. And we're going to, because it's equals, we're going to use PPD. If we look this up on our calculator using the method before, we will find probability x equals 2 equals 0.18393. Now, if we look at part B, that there are no wrong numbers in a full week, so a probability x equals 0, but now our lambda has changed because we're looking at a full week. Before it was lambda equals 1 for per day, now we want 7 days, so there must be lambda must now change to 7. So we look up probability x equals 0 with lambda equals 7 or mu equals 7, and we end up with the probability of 0.000912. Okay, so what we're doing here is looking at that it has more than 4 phone calls a week. So probability x is greater than 4, so this is going to be a PCD one. It's a cumulative one. But when it becomes PCD, it only works up values up to and including. So if you put 4 for PCD, what it does, it works out it's the probability of 0, 1, 2, 3 or 4, and it works out that cumulative probability. But when you're looking at greater than 4, you want 5, 6, 7, 8 and etc. So what you do is work out PCD of 4, and that will give us this probability here, and that's the probability of 0.172 9916. But we want this probability here and above. Sorry, I should indicate that. So just take that probability away from 1, because we know that all probabilities add up to 1. And if we take 1 minus 0.1729916, we get 0.827. And that's the basics of Poisson distribution.